So while I went away for just a little bit, I actually was configuring a little demo that I built up that has 10 high brightness LEDs, 1 through 10, and then each of those is the switch is actually, or the power supply is actually routed through one of the differential multiplexer cards. It's being used strictly as a, it's being routed through the digital multimeter, so we can make voltage measurements. So each time the power supply channel will get closed, routed to the particular LED of interest, and then make a voltage measurement for that device under test. There's also a number of thermocouples, one thermocouple for each of those, and then I have an external thermocouple right here that allows us to do some manual adjustment of the temperature. Since these are in an enclosure, it doesn't really allow it to do much other than just see a standardized or standard temperature. It does change over time, but it takes a little while. So I'm just going to show you how we did how to perform that channel setup, and then some of the key features of the instrument as we go along. So when the instrument is first booted up, again, you'll see the indication here of what channels you have available. If you want to check which cards you have in which slots, very simple. There's a control key here on the front panel. You press control and you'll see that each of these slot locations is then given a number. Here we've got MC3065, which is our multimeter in slot 1. We've got the MC3324, the 24 channel multiplexer card, slot 2, and then the MC3132 is going to be in slot 3. If you want to control each, you can press highlighting which instrument you want to control, so you can use the right and left arrow keys to move. Now we can go to MUX32, we can go back to 24. If you want to control it singly, you can press the single key, and now we have access to all of our different switches or cross points. So you can have the high-low inputs and then each of the channel locations. Page down is going to give us more information. You'll see now it goes 1 to 20. We can go here and move each of the channels, and we can close that channel 8 and then open it again using the OK key. We can also separate the banks, so we don't need to use it as as 2 banks of 12. We can use it as a single bank of 24, or the opposite. Let's return and go back to config. Okay, so what we're going to do is set up a scan list, and we're going to set up that scan list to route this voltage signal, the power supply, through through one of the switch cards to power one of the LEDs, or each of the LEDs in sequence, and then we're going to make a voltage measurement at each LED, and then we're also going to make a thermocouple scan afterwards. So again, we have a thermocouple underneath each of those 10 LEDs. But first, let's start. We're going to create a scan list. The scan list is going to hold all of the information for that particular experiment. Or that particular procedure. So the scan list, we're going to hit new. We can delete the old list name, and now we're going to change the cursor to get us onto the keypad, and we're going to select, let's just call this demo. So again, I'm just using the right and left arrow and up and down arrows and the OK to select, and do that. And now we're just going to select OK, and now you'll see that our new scan list has the name demo. Sweep is going to give us the number of sweeps. That's a default of infinite or 1. Infinite is going to scan until we stop it or the power shuts off to the instrument. And then sweep is going to be a number. And again, it defaults to number 1. If we wanted to do 10, select the number and press 10 on the keypad, select OK. Or we can go back to 1 and then hit OK. In this case, we're just going to leave it on infinite because we're just going to set this up to rattle on for a little bit. Trigger mode, again, absolute time, auto, manual, external trigger. You can trigger on an alarm. Quite a flexible trigger environment or trigger modes. We're going to leave it on auto. And interval. So an interval is going to separate it's going to define the period of time or the dwell time between trigger events or scans. You can imagine you may want to take data, you may want to collect temperature data at 10 points, but you only want to do that every 10 seconds. You would set the interval to 10 seconds here. Again, you could just select OK or enter one of the values, and it's given in hours, minutes, seconds, and milliseconds. We could set that to 0. So if we wanted to do 10 seconds, we would do this. And now every 10 seconds it will go and perform another scan. In this case, we're just going to let it run as quickly as possible. So I'm going to set that to 0 and hit OK. And so now we've created a scan list, and now we're going to populate the scan list with the channels and define each of the channels that we want for this list menu. So let's go to Edit, and that's going to bring up this demo table. And so now what we're going to do is populate the table. Again, in this case, we've got the digital multimeter in channel 1, we've got the thermocouples on channel 2, and we've got voltage routing and measurement on channel 3. So let's start out with the voltages. So that's going to be the routing of the voltages, which is going to be channel 3, or the 300s here. And so we're simply going to press New to create a new channel. It's going to go to default 201. Remember, we have a DMM in slot 1, so all of the 100s are now taken up with measurements. We're not going to actually do any switching in that particular position. So then that goes to the next value, or the next card slot, that's going to go to 2. So all of the 200s are now that 24 channel differential card that we have there. And all of the 300s are going to be the 32 channel differential card that we have here in channel 3. So we're going to take a look. Instead of 201, we're going to start at 301. So you can use the keypad to enter that and press OK. And now for 301, remember, we're going to route voltages, and we want to make a DC voltage measurement. So we've got a DC voltage function here. Some of the other functions we have available to us: AC volts, 2-wire ohms, 4-wire ohms, temperature, frequency, period, and sensor. Sensor allows you to fit this quadratic equation using different user-defined values. You can, let's say you have a pressure sensor, you can have this instrument, or you can have that particular channel reading the pressure sensor directly, scaling it appropriately, and also giving it the correct units. But for this, we're going to be routing voltage. So let's go over to DC volts. We're going to stay with auto range, but we do have a selection of ranges available to us. I'm just going to stick with auto. Now let's hit next and take a look at scaling. Scaling, again, we could scale using these weighting factors if we wanted to adjust it. We're just going to be doing a straight voltage measurement for this, so we don't need to use that feature, but I wanted to show it off. And here we've got the alarm. We're going to go with none, but we could go high, low, or none. And again, if we select one, we can then choose one of 4 alarm channels, which are indicated here on the front panel, and we can give it the values that are considered the limits for that high and the low. Let's go back up, and we're going to go to none again. Go over to advanced. Under advanced, we've got a few things that are very important. If you've used a digital multimeter before, this is going to be an old story, but if you are new to a digital multimeter or integrated measurements, this is going to be the integration, or INTEG here, is going to give us control over the length of time for the integration for each measurement. And that is given in power line cycles. Here in the United States, we have a power line cycle that is 60 hertz, so you want to integrate over the power line cycle to minimize the amount of noise coming from the power line, which is a large source of noise. So you want to integrate 1 over 60 hertz. That turns out to be about 16.6 milliseconds. And so that each measurement is going to take a minimum of 16.67 milliseconds. It's a little bit longer than that, depending on how you have it configured, but 1 NPLC is a standard measurement setting for a digital multimeter, so as a default it comes up as 1 NPLC. But you do have a number of adjustments that you can make here. You can also do a user-defined NPLC, and then all the way up to 200. And the moral of the story here is, the longer you integrate, the more noise rejection you're going to have, but the longer the measurement is going to take. So there is a balance between speed and accuracy with the NPLC setting. The impedance, we're going to leave at 10 mega ohms. Auto zero, if you enable auto zero, it's going to have long-term stability on the measurement, but it is going to take a little bit more time for each measurement that you make. You can do off for auto zero, but if you're going to be making measurements over longer periods of time, hours, days, weeks, you're going to have long-term drift, or it's very likely that you're going to have long-term drift because of the temperature difference in the environment and the instrument over that time period. So if you want long-term stability, you can use the auto zero on. If you want speed, you can turn auto zero off, but again, if you turn auto zero off over a longer period of time, you could see drift, so it is advisable to periodically come back and do an auto zero measurement. And then delay, typically you would set this to auto, but again, if you wanted to go faster or you wanted to specify how long you waited at each switch point, you could set the delay value, again, using the keypad. We could go to 10 seconds if we wanted to. In this case, again, we're just going to stick with auto. And we're going to finish up. So now we've configured channel 301 for DC volts, and we want to take that same channel because we have 10 identical switch setups, 301 through 310. We might as well just use some of the usability features here. We're just going to copy that channel. Again, we have a few different things we can do. We can copy one module over to another, one channel over to another, or one channel over to multiple channels. We're actually going to do channel, and now target channel is the source channel is 301. We just configured that channel. Now what we can do is we can take a target channel 302, 303, 304, 305, 306, 307, 308, and I'm just right arrow OK, and 310. So now channels 302 through 310 are going to be identical to channel 301. And we'll press done. And now you'll see we populated that list from 301 to 310 with DC volts. Now we have another, remember we have 11 thermocouple channels that we want to measure as well. So those start on channel 201. So we'll select 201, and then we're going to left arrow over to temperature. We've got thermocouple, RTD 4-wire, RTD, thermistor, thermocouple. So these are type K thermocouples. And so I'm going to go over to type K. We've got a number of types available. And then we can select units, Kelvin, degrees C, or degrees F. I'm going to stay with degrees F. We can also pick the precision. And again, we have the ability to do scaling, alarm, and advanced measurements on that. In advanced, you'll see when we select thermocouple, we have thermocouple check. That will tell you, or it will take a log of that thermocouple reading if it determines that a thermocouple is available or has a short. Thermocouples are susceptible to breakage. This is a way to mark or indicate that that thermocouple has been broken in your data record. With thermocouples, again, we also have a few different, we need to make a reference measurement in order to establish a temperature. And so for this, we have the ability to do fixed internal, which is a cold junction compensation on the main attachment board, or we have an external reference. And this is asking we need to have an external reference connected in order to make that measurement. So in this case, we're going to select internal, which is going to use the cold junction compensation in order to make that calculation on temperature from the thermocouple voltage. And again, auto 0 and delay are also available. So now we've got 201 through 210. Oh, I'm sorry. We've got a 201 temperature. We want to copy that channel, and we want that channel to go through, that setup to go through 202 through 211. And once we get here, 211, and we hit done. So now we populated the entire list. We're going to do a sweep from 201 to 211 for temperature and 301 to 310 for voltage. And we just press down and hit OK. And now we've got our list populated. So now that we've created a scan list, let's save it. And this is going to save to the internal drive. And we press OK. And we're just going to save this as demo. And press OK. And now it will save that